The technical data of inductive loads such as air conditioners and induction motors are always written on the nameplate of such inductive loads. Given all those technical data, how do you determine the sizes of the wiring cables for such inductive loads? If you know or you want to know more, please follow me in this video as we use examples to illustrate the calculations. Moving on with the examples. Example 8, determine the wiring cable size of a 2 horsepower, 230 volts, 50Hz, 0.85 power factor air conditioner, given that the length of cable run is 20 meters from the 230 volts phase voltage MCB distribution board. Question B, what is the size of wiring cable of a 10 kV, 12 kilowatts, 230 volts, 50Hz single phase induction motor? Length of cable run is equal to 30 meters from the 230 volts phase voltage MCB distribution board. Neglect possible losses in A and B. The board is actually a 3-phase board, but the single phase or the phase voltage of the board is 230 volts. We move on and find solutions to the two problems. Solving the problems. A part, when one is dealing with air conditioner, which is an inductive load. An air conditioner, being an inductive load, draws both reactive power and the active power. The apparent power is the factor sum of both the reactive power and the active power. So, solving the problem here now. The power factor from the question, the power factor is given as 0.85. Now, we have the active power denoted by P, which is equal to 2 horsepower, according to the question. Now, the apparent power S is equal to the active power over the power factor. And now, P, which is the active power, is equal to 2 times 746, because 1 horsepower is 746 watts. So we multiply it by 2 since we have 2 horsepower and we are having for 1492 watts. Now, given us that S is equal to P over the power factor, S is equal to this, because if the power factor is 0.85 and we are having this as our apparent power. So in calculating the current, the current being drawn by an inductive load, for one to calculate it correctly, one has to make use of the apparent power, not the active power alone. The active power in watts, that should not be the power that is used in calculating the total current, but the apparent power in kVA or VA. That is the higher unit of VA, is what we call kVA. So otherwise, if you use wattage or the active power to calculate the total current drawn by an inductive load, it will be incorrect. So the total phase current for the AC now is equal to the apparent power divided by the voltage, which is 230 volts, and this is the current. Then the length of cable run is given as 20 meters. Using standard cable technical brochure, voltage drop VD of 2.5 mm square, PVC, 1 core copper cable is 15 millivolts per ampere per meter. So, and that is to get the total voltage drop in volts. We need to multiply 15 by the current which is 8.1, and the total distance, which is 20 meters. Then we divide the result by 1000, and we get 2.43 volts, which is less than 2.5% of 230 volts. And the interpretation is that between the location of the MCB distribution board and the air conditioner, we have a voltage drop of 2.43 volts, which is still less than 2.5% of 230. So in other words, if we subtract the voltage drop of 2.43 from 230, we still have approximately 228 volts, which is adequate to make the air conditioner to function properly. Alright, therefore the right cable size is equal to 2.5 mm square, 1 core PVC low voltage copper cable, okay, in PVC conduit. And we have the size of the miniature circuit breaker being 15 amp, 15 amp single phase, because the air conditioner we are talking about is a single phase load. So the guiding principle is that the size of the miniature circuit breaker should be less than the current carrying capability of the wiring cable. In this case, the size of the MCB, which is 15 amp, is less than the current carrying capability of the 2.5 mm square 1 core PVC LV copper cable. And here is the simplified circuit diagram. This is the AC, 2 horsepower AC, the circuit breaker, the switch, and the wiring cable. We have for life, we have 2.5 mm square. For the neutral also, we have 2.5 mm square. And then we can have 1.5 mm square copper cable as well as the earth continuity cable or earth continuity conductor. It's actually a cable, not ordinary wire. So this is the green cable that is being shown there. And that ends up the solution to the A part. Moving on to the B part. The active power P is equal to 12 kilowatts. That is 12,000 watts for the induction motor. Then the reactive power Q is 10 kVAr, which is equal to 10,000 var. Then the apparent power is the factor sum of the active power P and the reactive power Q. So this is how it is done. And then this is the answer. So having the apparent power being 15,620 VA, the phase current of the induction motor, that is the induction motor current, is apparent power S divided by the phase voltage, which is 15,620 VA divided by 230, and the answer is 68 ampere. Now, length of cable run is given as 30 meters. Then using cable technical brochure, 25 mm square 2 core PVC stroke SWA stroke PVC copper cable in ground can carry 128 ampere current and has voltage drop of 1.7 millivolts per ampere per meter. So giving a total voltage drop of 1.7 times the current, which is 68, then times the length of cable run, which is 30 meters, and it's giving us this in volts. And then the answer is 3.47 volts, which is less than 2.5% of the 230 volts, which is the phase voltage. Therefore, The right cable size is 25 mm square 2 core PVC slash steel wire armor slash PVC copper cable. Then in this situation, one may not be able to use the MCB distribution board because the MCBs, one may not be able to have a readily available MCB of 100 ampere rating. So that is why I wrote here that it's either the supply comes from the distribution board DB or it comes from cubicle MCCB, that is encapsulated model case circuit breaker. That is the meaning of MCCB, is model case circuit breaker, and it can stand alone when it's enclosed in a cubicle. So, and that is it. The 100 amp SPN, that is single phase with neutral, because we are switching both live and neutral lines, so that's why we have SPN there. So, and this 100 ampere is less than the current carrying capability of 25 mm square. This one can carry up to 128 ampere. This 25 mm square, it can carry up to 128 ampere. So, and the principle, the guiding principle is that the current rating of the circuit breaker should be less than that of current carrying capability of the cable, which is 128 ampere in ground in this situation. So, and here we have a simplified circuit diagram here. This is 10 kV, right? 10 kV, and then we have the cubicle MCCB here. So the supply voltage is 230, and we have a fuse switch here. That is the SW there. The active power is 12 kilowatts, and this is the induction motor itself, and this is the cable size. All right. So it's an armored cable. So we use the armor of the cable as the earth conductor in this situation. So it serves as ECC, which means the armor is the earth continuity conductor in this situation. And that is the end, or this ends the solution to the B part. So if the video is found useful, please consider subscribing to the channel. That is my channel, JK Solutions. Thanks for watching.